Hey everyone, and welcome back to a new 4D Systems project. Today we're going to be creating a simple 8-bit art studio where you can draw and save artworks using a 4D Systems display. Let's take a look at how this works. The idea for this project is pretty straightforward. I'm going to be making a grid canvas that you can draw on using touch, inspired by the 8-bit style of retro video games, where a single cell in the grid is given a color, and when a group of cells come together, they create an image or silhouette. I'll be incorporating a touch-based drawing canvas, a color picker, a few different grid sizes to choose from, and then some basic controls like reset, save, erase, and a gallery to view any saved artworks as well. For this project, I'll be using a Gen 4 ulcd 5-inch capacitive touch display. I'll be connecting the display to my computer using a Gen 4 UPA breakout board, and the widgets and code writing will all be done entirely in the Workshop 4 ViSi environment. So let's launch Workshop 4 and I'll show you the completed project file and walk step by step through my process. So here is the file for this project. As usual, I always like to bring in my widgets and set everything up visually first and then go on to completing the code. So we can ignore the code for now. I decided to build the main drawing screen first on Form 1, even though it is not the boot screen for this project. This is because it is not only the most complex screen, but also the most important one. It's the screen that the user will be interacting with most of the time. I have a couple of widgets here, those being the color picker, which can be found in the Inputs tab, and then I have some fancy button and user button widgets, which can both be found in the Buttons tab of the Widgets menu. After bringing them onto the display, I simply resize and place them where I thought was most appropriate according to the 5-inch screen that I am using. So you can see that if I drag in a fancy button, for example, I can then drag it around and resize it by stretching. I can also come over to the Properties tab and have complete control over things such as its width, height, and placement. I also change the text that is being displayed by changing what is written here in the caption option. I've also slightly changed it visually by adjusting its color and font as well. To keep the project organized, I changed all of the names of the buttons in accordance to their function. So for example, the gallery button is simply named gallery. This makes it much easier to reference in the code instead of using default names such as fancy button 1. Of course, the naming conventions are up to personal preference. The last thing that we need on this screen is the grid, however I'll be handling that entirely with code, so I'll come back to this later. Onto Form 2, this will be the screen that actually boots when the display is powered on. I added a new form or screen into the program by heading over to the System Media tab and clicking on the Form option. This brings a blank page into the program. For the title, you can use a static text widget from the menu and drag it onto the display, and then you can customize it as you would like, similar to how I changed the font for the caption on the fancy button widget. Or as I've done here, what you can also do is simply import a PNG and place it onto the screen. For the buttons, I'm using the same fancy button widget as the last form. I adjusted its height and width and then copy and pasted it over to make 6 buttons. I've also changed the caption that's being displayed and the names for the widgets. What will happen here is that the user will be presented with this opening screen in which they can choose the size of the grid that they would like to draw on. This will then direct them to the screen where they draw, and the size of the grid will of course be determined by the option that they choose here. Activating the appropriate grid will also be handled in the code. The final screen is going to be a gallery screen, where the previous saved artworks will be stored and you'll be able to navigate through them. This screen is also really simple and just has 4 buttons: Previous and Next to navigate between artworks, a delete button if you want to get rid of a saved artwork, and finally a back to studio button so the user does not get stuck on this screen once they are done. And that is pretty much everything for the widget setup of this project. Now all that's left to do is take a look at the code to see how all the functionality is achieved. So let's quickly run through this. In this program, we are targeting a Gen 4 ulcd 5.0 DCT. Then importing the standard color, visual, and color picker routines, along with the generated constants file from the ViSi project. That constants file is what gives us access to the widget names like iSave, iErase, iColorPicker, and so on. After that, I define the key layout values. The color picker position is set with CPU on top, left, width, and height, and the drawing area is controlled by draw area min, max, and size. So instead of hard coding the canvas everywhere, the main drawing area is basically defined once as a 360 by 360 pixel square. This will vary depending on the display that you are using. Inside main, the program enables touch, mounts the SD card, clears the screen, turns on transparency, and then loads the ViSi image control files using file load image control. The program then counts how many saved images already exist, and that count is later used when saving new drawings, so each artwork gets a new file name like image0 or image1. Before showing the main drawing screen, the program calls choose size. This is the grid size selection screen. It displays the size buttons, waits for the user to press one, and then returns a number like 5, 8, or 10. That returned value becomes the size variable, which controls how many cells the canvas is divided into. The draw screen size function is where the actual drawing gets generated. It clears the screen, then uses a loop to draw the grid. So if the size is 20, the 360 pixel canvas gets divided into 20 sections. If the size is 5, it gets divided into 5 sections, and so on. The main loop then constantly checks touch input. If the user presses a widget, the code checks which widget was touched using item image touched. That's how all the buttons on the drawing screen, such as the reset, save, and erase buttons, are handled. The most important part is the drawing logic under touch moving. When the user drags across the canvas, the code reads the current touch coordinates. It then checks whether the touch is inside the drawing area and snaps the X and Y values to the nearest grid cell. Once the coordinate is snapped, the code fills one cell using GFX rectangle filled. If erase mode is on, it fills that cell in black. Otherwise, it fills it with the current color, which is the currently selected color from the color picker. The color picker is handled by update color picker XY. So the color picker is not just a static image. The code is actively reading from it and updating the selected color. The save function is another important section. When iSave is pressed, the code creates a file name, opens it, and captures only the drawing area. That means it saves just the artwork, not the buttons or the color picker that is around it. Onto the final part, which is the gallery system. This opens those saved image.gci files using OpenImage. This checks whether the file exists, and if it does, it displays it. If it does not exist, it draws a red placeholder box with a cross through it. The delete function is a little more involved. When the user confirms deletion, it erases the selected image, counts the remaining files, and then renames the later images so the numbering stays clean. And that is all of the essentials that you need to understand this code. So overall, this code is quite long. However, it's only built around a few key systems, those being the ViSi widgets, touch input interaction, grid maths, and mostly the color picker. So now all that's left to do is head over to the home menu and upload the project onto the display. That is everything for this project. If you would like to take a look at any of the products that are used in this video, please visit our website. If you have any questions or concerns, please visit our forums and resource center, And of course, don't forget to subscribe for more tutorials and videos. Thank you for watching and see you next time.